Okay, good morning, Professor David Delosreyes. My topic for this session will be college algebra, and this will now be lesson 80. We are almost done with college algebra. Okay, let's proceed. The My topic for this session will be college algebra, lesson number 80, and the title of the topic will be example problem on slope computations. Meaning the problem will be related to slope computations. Okay, let's try to bring out an example problem for tonight or for this morning. Find the equation of a line passing through a point with coordinates 3 and 1 and parallel to the line. The given equation of the line is y equal to 8x plus 9. We got a root word here, parallel. Okay, and it passes through the point with coordinates 3 and 1. The equation of the line is y equal to 8x plus 9. The number one step on how to bring out the solution of this is to bring out the graph of the given line. We must have to plot this one here. Okay, to plot this given line, okay, when x is 0, am I still in camera? When x is 0 to this equation here, y will be equal to 9. Because to plot a straight line, we just need 2 points, then connect the 2 points. And the specific location of the 2 points are actually at the y-axis and x-axis. So when we assume that the value of x is equal to 0, we could compute for y. And it passes through the y-axis at that location. So in here, when x is 0, y will be equal to 9. So the point with coordinates 0 and 9 is actually the y-intercept. It is this. 3, 6, 9. Right? When x is 0, the ordinate is 9. So this is the point. The line passes through this point here. We reverse the operation. When y is 0, to this equation here, x will be equal to negative 9 over 2. So the point with coordinates negative 9 over 2 and 0 is actually the x-intercept. Negative 9 halves is actually, this is 3. A little bit, that will be negative 4.5, right? This one. So the line y equal to 2x plus 9 passes through the x-intercept at this location here. And the coordinates of the x-intercept is in negative 9 halves and 0. So if we try to connect these 2 points here by using straight edge, okay, this will be the line, and the equation of that line is y equal to 2x plus 9. Right? What's next? The slope of this line is actually m is equal to 2. H plus. It should be, they call this slope upwards to the right. The slope of the line is actually m is equal to a positive 2. Meaning the line is upwards to the right. It falls under the first quadrant, right? What will be next? After plotting the given line, the problem says we will find the equation of a line which is parallel to this and passes through the point 3 and 1. This is 3 and this is 1. So this is the required point. Meaning the line passes through this point here, and the coordinates of that one is actually 3 and 1. Right? So how could we solve for the equation? Since the first line and the required line are actually parallel, uh, their slope will be the same, right? So the slope of this is also equal to 2. They're parallel, right? So if we try to bring out or solve for the equation of this one, we will still be using the so-called slope-intercept form. That is y is equal to x mx plus b, right? We now know the slope of the required line. We know a point on the straight line, okay? We know a certain point, and that certain point is actually 3 and 1, meaning the required line passes through this point. So I place it here. At the location 3 and 1, this 3 and 1 must satisfy this equation here. Okay? Because 3 and 1 lies on the required equation, and the equation of that line is actually for the meantime y is equal to mx plus b. Right? So if we try to put x equal to 3 and y is equal to 1, why is that so? We will substitute the value x equal to 3 and y equal to 1 back here. They must satisfy it because this abscissa and ordinate passes through the given line. That's the meaning of that one. That's the term must satisfy. Okay? So if we try to substitute, y is equal to 1, right? Slope is 2. At the location 3 and 1, the value of x is 3, so this will be 3. This 2, this 1, plus the unknown y-intercept. Because b here is actually, for the slope-intercept, form is actually the y-intercept. Right? So if we try to substitute the value of x equal to 3, am I still on camera? X equal to 3 and y equal to 1 back here, okay, this will be the resulting equation, and the only unknown now is the y-intercept of the required line. So actually, this is now a linear equation, right? That's why our topic is actually a linear equation. And the only unknown is b. Okay? So b now will be equal to 1 minus 6. If we transpose this to the left and we try to rearrange, b now will be equal to negative 5. So meaning to say the required y-intercept of the line is actually negative 5. So if we try to go back to this equation here, y now, okay, will be equal to 2x. And what is the computed value of the y-intercept? It's negative 5. So this will be our answer. And to plot the graph of this one, it's easy. When x is equal to 0, y is equal to negative 5. So the y-intercept is at the location 0 and negative 5. Okay? It is this. When x is 0, y is actually, this is 3, this is 6, this is 5. The required line passes through the y-intercept at this location here, and the coordinates of the y-intercept is 0 and minus 5 as per computation, right? And if we try to reverse the operation, when y is equal to 0, x will be equal to 5 halves. If we put this to be 0, x will be 5 halves. So at the location 5 halves and 0, that will be the x-intercept, right? At the location 5 halves is actually this point here, this one, right? 5 halves is 2.5 because this is 3, right? So this is 5 halves and the ordinate is actually 0. So the required line passes through the x-intercept at the location 5 halves and 0. It's this one. So if we try to plot the required line, you just get your, what I call this is straight edge. Okay, we'll do it like that. So this is the required line. As you can see it, they are in parallel, right? Parallel meaning it is just like the rails, right? They are in parallel. Okay, they are in parallel if their slope are actually equal. So from now on, if we see parallel lines, the slope of the two lines will be equal. So that's the key to the solution of the problem, because it says find the equation of the line passing through train 1 parallel to the given line y equal to 2x plus 9. Okay, so they should be, the equation of this required line is y is equal to 2x minus 9. Okay, they are almost the same except for the y-intercept. Their slopes are equal because they are parallel lines. Okay, that's it, guys. That's the way how to solve this problem. It is a problem on the so-called slope. Okay, the key to the solution is by using the so-called slope-intercept form. Y is equal to mx plus b, where m represents the slope of any straight line and b represents the so-called y-intercept. Okay, good morning from Los Angeles, Professor David J. De Los Reyes.